Salutations from space and aloha from Earth, friends. Gemini Brett here from the School of Earth Astrology. Going to explore the spinning Earth here today. The spinning Earth, which makes the day and the night, right? We experience Earth's diurnal or daily rotation, which is called the primary motion, as the spinning of our sky. Right? The Earth spins from the west to the east, which is why the sun rises in New York before it does in LA. And we here on Earth experiencing the spin of our planet, this daily rotation of our planet, is the rotating sky. So we experience the sky rising in the east and resting in the west. It is this primary motion, this spinning of our planet, or spinning of our sky, our experience of that, that brings the planets through the houses, from the rise at the ascendant to the reach at the midheaven to the rest at the descendant, into the IC, the Imum Celi, the roots of the chart, where everything begins its daily climb to the ascendant once again. I've been putting up a series of videos for Stellarium astrology software, particularly used for astrology, as I love to teach astronomy to astrologers. And I've been downloading and going through each of the menu options, and we're at very basic levels of that. There's much still to do in my current Stellarium for Astrologers series. But I thought I would take a break from some of that minutia and actually utilize Stellarium to explore this primary motion on Earth, and specifically to explore how the primary motion is experienced in one place on Earth from another. So we're going to do a little globe trotting in Stellarium today. And where should we begin? How about here? I'm sitting in Richmond, California, and I cast this chart for 9:33 a.m. This is what that moment looks like in my local sky. Although it's cloudy out and I don't see all these nifty lines and whatnot, and oh, well, the only planet I can really see in the sky is the sun. I can barely see the sun at all right now. And regardless, nighttime is the right time. So what we're going to do is go to another place on Earth where the sun has already set, right? I could either move through time, or I could simply move west on Earth. So let's do that. I'm going to get less west of the prime meridian, which, as we know, now passes through Greenwich in the UK. Some debate about where maybe that should be. And you can see here that at this time, due east of me, somewhere in Spain, the sun is just now setting. Let's go a little further to the east. We'll get darkness, and let's bring Mars up here. In fact, I'm going to start in Ploiești in Romania. And the reason why is not only is it nighttime, I'm going to go back a few minutes, I guess, for this chart to agree with this time. Here in the Astro Gold Astronomy software, I can relocate this chart for this moment. Same moment in time, but another place, another time zone, right? So it is 9:33 a.m. on February 16th, 2023 here in Richmond, California, in Pacific time, is 7:33 p.m. on February 16th in Ploiești, Romania. So let's just utilize that chart. And we see that Mars has just culminated, which is what Stellarium is showing us here as well. Because while the ascendant is the intersection of the ecliptic or the heart of the zodiac, the path of the sun in Earth's sky. The ascendant is the intersection of the ecliptic with the eastern horizon. The meridian midheaven, or the reach, is the intersection of the ecliptic with the meridian, the north-south circle. And you can see Mars is just to the west of that line, that meridian line, which divides the eastern sky, which goes up, from the western sky, which goes down. The eastern sky ascends, the western sky descends. So the meridian, which is a local north-south great circle, it passes right through the zenith directly above our heads and through the cardinal directions north and south on the horizons. It goes through the nadir down here beneath our feet. It's a very important great circle dividing the sphere, the local sphere of your heavenly experience, in half, from the eastern side, which again ascends, and the western side, which descends, okay? So Mars here, just to the west of the meridian line, shows up on this northern hemisphere chart as the 9th house, right? And just to the right or just to the west of south. In temperate locations in the northern hemisphere, like in Ploiești, Romania, the meridian midheaven is always due south. So why Ploiești? Well, my partner was born there. But more importantly, I just have an opportunity to go very far north up to Scandinavia and all the way south down to the Horn of South Africa here. And for the most part, staying on land. We're going to have to sail through the Mediterranean a bit. But one thing I want to do with you here today is to go to different places in the northern hemisphere and in the southern hemisphere and explore the spinning of the sky. Now, importantly, this ecliptic plane, which is the plane that the planets travel through the signs, and most importantly, or most accurately, that's true for the sun. The ecliptic is Earth's orbital path about the sun, right? Let's say this is the sun and here we have Earth, all right? And so each year, of course, the Earth is orbiting the sun, right? On a plane called the ecliptic. I can't quite make it plainer, I guess, because of my arm, but you see what I'm going for, yeah? This would be, by the way, the sun's Cancer ingress. How do I know? Well, the tropical zodiac is tied to Gaia's spine, to the sword of our stone, to the world tree, to Earth's rotational axis, which in every moment forever leans towards 0 degrees tropical Cancer. So this is the time in our annual orbit of the sun when Earth's northern axis is leaning towards the light, that the sun ingresses tropical Cancer. The tropical zodiac, like so many sacred systems of ancient wisdom traditions, is directionally aligned. The cardinal directions, in these days we call Cancer a cardinal sign, right? You see, this is the cardinal sign aligning to cardinal north. It's Earth's rotational axis, the axis of the day, that defines the cardinal directions. True north is where the axis of our rotation passes through the North Pole. True south is down there, right? So if I get outside and I work with the North Star tonight, I will literally be facing Santa's place up here at the North Pole, all right? North is north everywhere on Earth. Now, the reason for the seasons is our rotational plane of our daily motion is tilted in respect to our orbital plane, which is the ecliptic, okay? And so Earth's orbital plane, the ecliptic, right? Here's Libra equinox and Capricorn solstice, the Earth's southern axis leaning towards the sun. So summer solstice in the southern hemisphere and winter solstice in the northern hemisphere. Here's the Aries equinox. Here's the Cancer solstice, right? Most light in the northern hemisphere because the northern hemisphere is leaning right towards the sun at that time. Of course, as we're orbiting, this thing needs to be spinning like 365 times as well. I can't do it all with a crystal and a globe, friends. What are you going to say? But you know, most globes that you do see are not oriented to the rotational plane, which is Earth's equator, but rather to the orbital plane, which is called the ecliptic. And the orbital plane passes through the tropics, through the Tropic of Cancer and the Tropic of Capricorn. Tropical zodiac, tropical Cancer, Tropic of Cancer. Oh, those sound alike, and for good reason, friends. For the most part, our solar system is relatively flat, and so we will find that in a chart, this circumference is the ecliptic, which is the path of the sun. It's the plane of the Earth. So from Earth's point of view, the plane that the sun takes in its annual course about us. It's the yellow curve you can see here. And as you can see, Mars is not right on that plane. Mars has his own orbital path, has his own geocentric nodes, which are from Earth's point of view where the path of Mars passes over the path of the sun, the ecliptic. But because the solar system is relatively flat, the planets stay rather close. What is that blue curve that just came in? Well, that's Earth's equator. And that is the plane of the rotation. So it's the ecliptic plane for planets traveling through the signs. Let me just, well, I think we're good there. It's the celestial equator, Earth's equator projected out into space. And Earth's equator itself, that is the plane of our day, of our rotation, of the diurnal motion. And it's that plane that brings planets through the houses. In any moment in time, the stars that are currently in the first house, which are beneath the ground, the eastern horizon, that's over here, they will be first to rise. Do you see why this is called the first house? Let's actually move this through time. I'm just going to let the world spin a bit. And we're going to see Mars moving from that height there near the meridian, from the 9th house, which is a cadent house. That means falling. Now coming down, Mars is in the 8th house, and then coming into the 7th house, and then Mars will set into the horizon here. Now you might be surprised to see some strange things happening on the screen, like the ascendant, which we are so often incorrectly taught is always due east, is not. The ascendant rudders back and forth between the solstice points. Only the equinox points rise due east and set due west. So if we want to have an image of the spinning sky, we're going to want to bring in this celestial equator. So again, that's Earth's equator projected into space. You can see how it's moving through the cardinal directions, east and west. The plane of our rotation, Earth's equator, is perpendicular or square to the pole, which defines the cardinal directions north and south. So of course it moves through the cardinal directions east and west. You know, I think I'm going to take the ecliptic away and even take the planets away here. And we'll just observe the spinning of the sky. And we're going to observe this from many places. So why did I choose Ploiești, Romania, to begin our globe-trotting sesh? Not so I could work that nifty jargon rhyme, but because, again, there's a ton of land up to the north and a ton of land down to the south, so we can actually keep our feet on the ground as we are exploring the spinning of the sky from many different latitudes, both north and south of Earth's equator. And we're going to start here actually about halfway exactly between the equator, which has a terrestrial latitude of 0, and the North Pole, which has a terrestrial latitude of 90 degrees. the north, the South Pole, terrestrial latitude of negative 90 degrees is the convention, or we could say 90 degrees south. Okay? So I'm actually going to shift, or just walk slightly north of Ploiești in Romania, and go 3 arc minutes further to the north. And now we're at an exactly 45 degrees north latitude, exactly halfway between Earth's equator and the North Pole. So just witness how here in the northern hemisphere sky, I'm facing south. And the reason why is, again, in the northern hemisphere, this is where we are going to find the planets moving through the sky. Maybe most importantly, the sun. Let me speed this up so it's daytime. There, okay. We used to call this clockwise motion, as we call it today, sunwise. Well, some of us still do. And that's because in the northern hemisphere, and this is true as well in the chart, which is modeled after the northern hemisphere sky, that as we move through the hours, you're going to see the whole chart spinning clockwise. So watch, here's moonrise now, here's sunrise, and then the sun comes up to the reach, and then the sun will go rest in the west, right? And you see how the whole thing is moving like a clock? Well, this is what clocks are designed upon, the moving of the light through the northern hemisphere sky. The sun moves clockwise in the south, so does Mars and Jupiter and Saturn, Mercury, Venus, Moon, Orion, the Lion, the ecliptic constellations, which are the zodiac, and more, okay? Again, I'm going to take the ecliptic away, and oops, wrong one. Getting out of control here. I'm going to take away the sun. Let's slow that down again. Because I just want to explore the spinning of the sky. And the spin, once again, is not about our orbital plane. That's the ecliptic. It's about our rotational plane, and that is Earth's equator. Okay? I'm going to bring here in Stellarium as I can an equatorial grid. So down here, kind of the bottom menu bar of Stellarium, we'll see an option to bring that in. And now you can see here, down below the ground, which of course you won't see outside with your eyes in Ploiești, Romania at any time, but this is the South Celestial Pole. The celestial pole on the other side of the sky is quite visible, so let's turn our bodies around and have a look towards the north. Now, I should have said this before we began, but we are kind of defying the human experience here. We're looking both east and west at the same time. You can't do that, right? We need like spider eyes. Your experience is going to be a lot more like this, right? And if you want to move from the north and go have a look to the east, you've actually got to turn your body. All right, so Stellarium lets us have a wider view, as does the astrology chart, where we can literally see beneath the ground, right? The horizontal line of a quadrant house system chart is the horizon, right? The ground beneath our feet. This line of the MC and IC is the meridian, which divides the eastern ascending sky from the western descending sky. Okay, a little bit about the quadrants. So when I'm looking north, my heart's to the north, then east is on my right, and west is on my left. And that means the east to west spinning of the sky is going to be anti-clockwise or counterclockwise in the north. You'll notice, and Stellarium makes this quite easy to see, that the sky is spinning about 1 point. That is the celestial pole. It is the center of this grid. In our day and age, we're very fortunate in the Northern Hemisphere observational experience to have a North Star. So we call it North Star. It hasn't held that name forever. It won't hold that name forever either. Because where the pole of Earth points in space is changing over time. This is called the third motion of the Earth, axial precession. It causes the precession of the equinoxes. It causes the constellations of the zodiac to process across Earth's cardinal directions to which the tropical zodiac is aligned. And it's what causes signs and constellations to shift over time if you're working with a directionally aligned zodiac, the Earth zodiac, the tropical zodiac, like I do. We can see in this some beautiful esoteric expressions like the turning of the ages, and there's more to say about that, but let me just define the three first motions of the Earth. The first motion, the primary motion, the daily rotation, bringing the planets through the houses. The second motion, our annual orbit of the sun, right? Bringing the sun through the signs. When we look at the moon orbiting us, that brings the moon through the signs, because look, if the signs are defined, as I like to say, by Gaia's spine, 0 degrees Cancer is where the north axis, the Earth's north axis is always leaning. 0 Capricorn, the southern axis over there. Well, just think about the moon going around the Earth every month, right? It's just Cancer and Aries and Capricorn and Libra. It's Cancer and Libra and Capricorn and Aries, Cancer, Libra, Capricorn, Aries, like that, right? As Jupiter's doing his jam about the sun, we here on Earth are experiencing Jupiter moving around the Earth in regards to the directions, the cardinal directions, right? Over the course of Jupiter's zodiacal transit, which is like about 12 Earth years, 11.86, but who's counting? We are. We should be. And of course, every day, because Earth is spinning, we have Jupiter also rising in the east, reaching and resting in the west. Yeah. All right. So Earth's primary motion, our daily rotation, which brings the planets and the signs through the houses. Earth's secondary motion, our orbit of the sun, which brings the sun through the signs. Our tertiary motion, or our third motion, is this axial precession. All right. So in our day and age, again, we're very fortunate, at least in the northern hemisphere, to have a pole star, which we call Polaris. Why? Because Earth's North Pole is generally pointing to that star. It's actually getting more aligned over the course of the next less than 100 years, where Polaris will be most aligned to the North Celestial Pole. What is the North Celestial Pole? I'm glad you asked. Gaia's spine, the world tree, our rotational axis, emanates from the heart of the Earth, passes through her terrestrial poles, South Pole and Santa's place at the North Pole up here, and then points to the North Celestial Pole in the sky. All right? Can you imagine where you might stand on Earth for that North Celestial Pole to be directly overhead? Did you guess the North Pole? You're right, except you can't stand there because it's wet. Maybe it's frozen, and then you're all good. Bring a coat, okay? So if you are standing right here, the North Celestial Pole, and in our day and age, Polaris, North Star, will be directly above your head at the zenith. And the spinning of the sky, due to the spinning of the Earth, is going to look quite unique up there. Let's go there in Planetarium and see how it works in Stellarium Planetarium Software. Before we do, let's guess where the pole might be if we were standing on Earth's equator. Right? So at Earth's equator, let's just go there now. Let's go to I guess Kenya here. If I'm standing there, now the equator, or the celestial equator, which is simply Earth's equator projected into space, that's going to be directly above my head. And the poles are down on my horizon. So we're already finding our way to a principle here that I call the lataltitude principle, which is this. The altitude of the celestial pole in your sky is equal to your location's terrestrial latitude. All right, the terrestrial latitude of the equator is 0. And if you're at the equator, the celestial pole is literally on your horizon. The terrestrial latitude of the North Pole is 90. And if you're at North Pole, the altitude of the celestial pole right above your head is 90 at the zenith. Okay, so we're going to need to bring in another coordinate system here, which is called the horizon coordinates. Let's just talk about altitude, which is up and down and also below the ground. All right, the horizon in any direction is said to be 0 degrees altitude. Makes sense, right? It's like right on the ground. And then as we go up 10, 20, 30, 40, 90 degrees, positive 90 degrees is up right above our head, which is the zenith. Okay, the point directly above your head when you're outside, inside, whatever. When you're standing up, I should say. Down beneath my feet, we find a nadir, right? Something we could never see because there's a whole lot of earth between me and that place down at the kind of bottom of my local space. And it has an altitude of negative 90 degrees. So we go from the zenith at 90, and we're coming down 80, 70, 60, 50, 40, 30, 20, 10, 0 at the horizon. You can see I didn't do that too well counting with my arm movements. But now we're going to go down beneath the ground, negative 10, negative 20, negative 30, all the way down to negative 90 beneath our feet. Stellarium has a wonderful grid to help us see these horizontal or horizon coordinates as well. Let me take the equatorial grid away for a moment. And you know what, instead of using keyboard shortcuts, I won't want to do this on the menu in case you're just learning your way around Stellarium. So there's the equatorial grid, and take that away. And then here's an azimuthal grid is another way to express a grid of horizontal coordinates, horizon coordinates, okay? Zoom in a bit. This is more like kind of our human view when we're outside. Maybe in my periphery, I can see northwest and northeast when I'm facing my heart towards the north like this. This is 5 degrees altitude. You can see written here on the sides. 10 degrees, 15, 20, 25. We're going to have to look up, right? And all the way up above our heads is 90 degrees of altitude, the zenith, which is why that says Z, okay? Let's start looking back down. I guess I could slow this down and smooth it out. Now we're looking down beneath the ground. Stellarium's letting us have a peek, and we're going all the way down to what you'll see here is Z prime. That's the nadir down beneath my feet. I'm gonna zoom out as the software will let us do. And we'll look at the horizon here. Okay, so 0. And now you can see, like, what are they? 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees of altitude, okay? And remember, we just kind of sorted out this, what I call lataltitude principle, that the altitude of your celestial pole is equal to your latitude on Earth, right? Or at least this is a theory we have, which we will confirm in Stellarium, because as we kind of were able to see by looking at the globe from space, the locations here on Earth's equator, like this spot in southern India, have the celestial equator directly above their heads and their poles on their horizon, right? So the equator, a latitude of 0, the pole on the horizon, which means it has an altitude of 0. That's why my silly term is lataltitude. The latitude of your earthly location, your terrestrial latitude, is equal to the altitude of your celestial pole in your sky. All right, so when we went up to Santa's place at 90 north terrestrial latitude, the North Pole, right now we find that because the North Pole is pointing to the zenith right above our heads, the North Celestial Pole is at the zenith. We're at 90 degrees terrestrial latitude. The Celestial Pole is at 90 degrees altitude. Make sense? So when we're at Ploiești at 45 degrees north, which is like other places I'm familiar at that same latitude halfway on Earth between the equator and the North Pole, or like Minneapolis, Minnesota, Salem, Oregon. Please fill in many places from the countries where you dwell or from your travel experience. That's what I've got. Stellarium could help us find many of those places too, which is pretty cool. But for now, let's just travel north and south on Earth from Ploiești here, right? You can see this arrow on the Stellarium map that just showed up. You can also see the latitude and the longitude, right? So now this is terrestrial latitude and longitude. Terrestrial latitude, of course, measured north and south of Earth's equator. So Ploiești at 45 north, halfway between Earth's equator, which has a latitude of 0, and the North Pole, a latitude of 90 north. I think let's go there. As far as the longitude goes, there's an important truth that I want to show there. But first, let us confirm that our terrestrial latitude is indeed equal to the altitude of our celestial pole. All right, so there's a couple ways I could show the celestial pole here in Stellarium. And one is to turn on this equatorial grid, because the center of the spinning sky is that place where our rotational axis, Earth's pole, is pointing in space, the celestial pole. Okay? I mean, I can take all of the stars away and show that thing to be true. And I mean, it's tricky with all of these grids happening here, and maybe with the spin. Let's zoom in a bit. And you'll see that this is in the green curve, 40 degrees of altitude, and this one 50 degrees of altitude. All right, so we're right between 40 and 50. Can zoom in another bit, and now we get 45 just showed up. Okay, Stellarium will also, if I go to the sky and viewing options menu over here, give me the opportunity with these markings to put the celestial poles in the sky. Okay, so there's a few options, as you can see. The ones that I'll encourage you to use, actually there's two options, is this one, celestial poles of the date. Okay, so let me just push that button. I'm now going to take the equatorial grid away just for a bit. And we indeed see that the NCP, North Celestial Pole, is here at this terrestrial latitude of 45 north, here 45 degrees north altitude, halfway between our horizon, which has a 0 degree altitude, and the zenith above our head, which has an altitude of 90 degrees. Yes? So the lataltitude principle, I'm halfway between Earth's equator and North Pole, 45 degrees north latitude on Earth, terrestrial latitude, and that terrestrial latitude is equal to the altitude of the celestial pole that's in my sky. In the northern hemisphere, the north celestial pole is in my sky. Let's confirm this truth by just going 5 degrees north on Earth from Ploiestromania. So I'm going to, in Stellarium, just highlight that latitude and push the up button a few times. And while we do, we expect that North Celestial Pole will climb. In fact, let's take this all the way to Santa's place. All right, so 46, 47, 48, 49, 50. And now we see the North Celestial Pole at the 50 degree altitude mark, where we are 50 degrees north of Earth's equator. All right, let's continue to 60, and we're going to find the North Celestial Pole, reach that next marker on the grid for 60 degrees altitude. All right, here comes 70, here comes 80, and let's bring the North Celestial Pole all the way to the zenith, directly above our head. Let's lay on our backs. Hope you brought your blankets, because where are we? I don't see the arrow anymore on the map. We're like on top of the map at the North Pole. And we know that because we can see here a latitude of 90 north. Terrestrial latitude, 90 degrees north of the equator, is literally Earth's North Pole, Santa's place. We're laying on our back, and we are seeing that the North Celestial Pole here is at the top of our sky. The top of the sky marked by the Z for zenith, the North Celestial Pole marked by NCP for North Celestial Pole, and at this place and only at this place on the Earth, they are one. Zenith, Z, and North Celestial Pole, one and the same. As I was saying before, we are blessed in our day and age to have a star that is so closely aligned to that North Celestial Pole in space, which is the center of our sky's spin. Wrong grid, but it actually works at the North Pole. There we go. Okay. So you can see that it's Polaris here, pole star, North Star, is not exactly at the North Celestial Pole. As I said, this changes over time with Earth's third motion, the axial precession, and it is actually getting closer and closer, the North Celestial Pole, to Polaris over the course of, I think it's the next 70 plus years. I'd like to have that number in my catalog, but it's not currently. But regardless, this is very close. So if you live in the northern hemisphere, it is super helpful to get to know North Star. Now, there's many tricks to finding Polaris, pole star, North Star. We can work with the pointer stars of the Big Dipper, for example, and let's get to that. But right now, I want to just say a wonderful trick to know. And this is true if you're in the southern hemisphere where you don't have a South Pole star at this time of the precessional ages, but you do have a South Celestial Pole. And we're going to go to the southern hemisphere and take a look at that, okay? Well, we're going to find stars that will help us find our way to Polaris, pointer stars, if you will. I'll show you how you can work with, the Big Dipper, asterism of the Great Bear constellation. Or also work with Cassiopeia here. But for now, let's work with the lataltitude principle. If I'm at Santa's place, drinking cocoa with the elves, 90 degrees north of Earth's equator, then I know the altitude of my celestial pole is 90 degrees. In other words, up above my horizon, right? The horizon is where I will find the celestial equator, Earth's equator. I mean, it's a very kind of unique place on Earth, obviously, the North Pole. And there we experiencing the spinning of the sky like a big top, right? Like we're in the circus, yeah. So the east to west spinning of the sky. And by the way, I can't even show the cardinal directions here when I'm at the North Pole. Why? Because at the North Pole, everywhere is south. So let's just go down to 85 north. And now we will see that the altitude to the pole, to the celestial pole in our sky, is not at the zenith anymore. Let's put the zenith back on with a Z. Okay, the North Celestial Pole altitude here is going to be at 85. Let's look up a bit and we can see that ring on this azimuthal or horizon coordinate system axis. Okay, let me take that grid away. And you know what? Let's head south a bit. We're gonna have to skate on ice or get in the boat, probably cruise through some icebergs, and I'm gonna bring it to like rather northern Scandinavia here. Hard for me to see which country I'm in. I'm guessing it's Norway. If I reset this location list, by the way, you know, I think I have to click here for Stellarium then to recommend some places close by, like Hammerfest. And sadly, Stellarium recently took country names away. So you have to know what country these places are in, and you know, I don't want to go there right now. So I'm gonna get to 70 north again, just by pushing this up button, I think. There we go. And actually, let's go down a little further. Let's go down to 60 north. And one thing we should expect to see is that the North Celestial Pole is at 60 degrees of altitude. There's actually, let me stop time here. There's an altitude measuring tool in Stellarium that you actually have to like add to your menu kit, and I will show you how to do that in a very different video. But I'm going to use it here and just kind of make a measurement from the ground up to the North Celestial Pole, and you're going to see 60. And if I could be very precise with this tool, it would say exactly 60. Why? Because of the lataltitude principle. The terrestrial latitude of 60 degrees north means that the altitude of the celestial pole will be 60 degrees above the ground, 60 degrees altitude. All right, well, this was a cool place to stop time. We're dealing with, well, dragons and bears. All right, so this constellation here, I imagine you know, or at least part of, it is Ursa Major, the big bear in the, I guess I'll say Western tradition. And then we have the little bear here. Strange bears in the sky, they have these long tails. I don't think you're going to find that true of the bears on Earth, okay? And probably the dragons you see here on Earth do have very long tails, as this one does. This is Draco, who's a very important constellation when we get into Earth's third motion and the precessional ages in that. I encourage you to get to know Draco in your sky. One way to know Draco is to learn your bears, and then you can find the tail of Draco the dragon, which passes through between the bears. Okay, you can see him coming up over this way. Draco's head's quite close to a very bright star, Vega, of Hermes' lyre, the harp in the heavens, and Hercules over here. Anyway, let's focus on the bears. So the North Celestial Pole is the tail star of the Ursa Minor constellation. Let me try this thing again. There. I want to just show one constellation at a time. The stars are not particularly bright. Polaris is certainly the brightest of the Little Dipper stars, which is a name we also use, an asterism name. Some say the little wagon. For Ursa Minor, the little bear. Kind of looks like a chipmunk here with a bear nose, doesn't it? But the Little Dipper, where this is the handle and this is the dipper. The stars at the end of the cup, Kochab and Pherkon, they are like naked eye visible, and even in like light polluted skies, like here in California's Bay Area. Many of these Little Dipper stars are pretty tricky to see, but the pole star Polaris is relatively bright. Magnitude of less than 2 is going to show up to your naked eye, even in very light polluted skies. There's also not too many bright stars in the zone, right? Vega over here is a rather bright star, as is, who are we seeing here? Capella. But remember that like we're kind of like going bug-eyed here, where I'm looking west and east at the same time. This is much more like the human view. And then I'm going to have to look up to see Polaris. So you know what, the thing I'm going to do is actually bring Polaris a little bit closer to the ground. What would I have to do to perform that magical act? I would have to travel south on Earth. Right? Remember, the terrestrial latitude is equal to the altitude to the celestial pole. So here at 60 degrees north terrestrial latitude, the pole star, or sorry, the north celestial pole also is 60 degrees altitude. Let's go down to like, let's cross the Mediterranean Sea and get into Egypt here, and we'll do 30 degrees north latitude. All right, so what is the altitude of the pole? It is 30 degrees. It's a third of the way to the top of the sky, where that top of the sky, of course, the zenith, has an altitude of 90, right? So as I zoom in here, let me zoom out. We'll see 10, 20, 30, 40, 50, 60, 70, 80, 90 at the zenith right above our heads. And now I can be like a little bit more in the human experience, right? Where again, I feel if I'm looking north, I can peripheral see northwest, northeast, maybe even a little bit further, right? And my experience isn't going to be like this. I'm taking kind of what's like a spherical experience and projecting it onto a flat screen, right? There's actually in Stellarium, there's many different ways that we can perform that projection. And that's here in the, I keep saying I'm not going to use keyboard shortcuts, the sky and viewing options menu. And then down in the sky tab in the lower left, the default is this stereographic, but we could do perspective or like a fisheye. This one, orthographic, is kind of looking at Earth. It's hard to say what it is, right? So there's lots of different options we can use, and the further zoomed out you are, the more difference that makes. I'm going to stick with their default view, which is stereographic now. But just please remember that as we are projecting a spherical or curved experience onto a flat screen, we're going to lose like the human truth. If you want to really see this and how it works in your sky, go outside, right? I can introduce you to some of these things on the small screen, but it's the big screen of the living sky outside that is your true classroom if you really want to integrate the astronomy with the astrology chart. All right, let's bring in some other stars here so we can learn some tricks for finding Polaris in our sky. Again, Polaris is only going to be above ground if you live in the northern hemisphere. Let's prove that to be true. Because I keep saying that your terrestrial latitude is equal to the altitude of your celestial pole, and that's true. If you're in the northern hemisphere, then the altitude to the north celestial pole is equivalent to your terrestrial northern latitude. If you're in the southern hemisphere, the altitude to your south celestial pole is equivalent to your south terrestrial latitude. If you're at the equator, let's go there now. A terrestrial latitude of 0, well, which celestial pole is yours? Is it north or south? Is the equator is it northern hemisphere or southern hemisphere? Yes. No. It is neither. And both. Let's let the sky spin. As long as we're here at Earth's equator, I'm going to take this as a mythal grid away. Maybe I'll bring in the equatorial grid. Well, let's see the sky spinning first. So at the equator, you get this kind of wheel experience. Let me slow it down a bit. And let's go look to the east. So you now can see like the north celestial pole on my left and the south celestial pole over here on my right. You can zoom in a bit. And you just get this spinning in this way. Actually want to change some of the projections to see if others have even better expressions of what I've seen in the sky. Yeah, maybe this Mercator or cylinder projections are the best. This is the ram horn's rise of the eastern sky. It is most clear at the equator. In other places, like I live 38 degrees north, I have to tilt my head 38 degrees north, or sorry, 38 degrees to see this. But hopefully you can see here the ram's rise of the eastern sky. You see Fountain of Youth. Tale for another time, but something I very much like to focus on in my Astronomy for Astrologers courses, because I think that truth begs us to actually reimagine the very history of the zodiacal development over time. All right, I'm going to go back to the stereographic and we'll put this thing away. So we can go now and look south, and there's the south celestial pole. Again, because we are on the horizon, it is on the horizon. Kind of surprised to see that doesn't quite look true. I'm going to try a button real quick. I think it's because I didn't necessarily have my feet right on the ground. No, something's off here for a reason I can't quite explain. Huh. As soon as I go from 1 north, where the south celestial pole is below the ground as it should be, and I go to 0, this is the place on Earth where that celestial pole should be right on the horizon. And that might be some kind of viewing thing, like a refraction. I don't know. I'm interested in seeing what happens when we turn around and look back over here towards the north. So I'm just turning my head from the south now, and I'm turning my head faster. Let me zoom out. Here's southwest. Now let's spin faster. We don't have all day. There's west, northwest, and now we're looking north. Yeah, you can't have both your north celestial pole and your south celestial pole above the ground. So something's just broken in Stellarium, and I don't know why. All right, let's get with the bear in the sky. I'm going to look north, turning left from facing east, and now I'm facing north. A little bit more of the human experience here. And you know what? I'm going to actually continue further south, and we'll just keep our eyes here on the north. And what we're going to see is that the north celestial pole now goes down beneath the ground. And as you might imagine, when I'm at a terrestrial latitude of 15 degrees south of Earth's equator, here in Africa in this moment, then the north celestial pole has an altitude of negative 15 degrees. In other words, 15, 5, 10, 15 degrees beneath the ground. Okay, so you're not working with North Star down there. As you can see, you can get just a little bit of the Little Dipper here, or stars of the Big Bear, to just barely rise, and then they'll set again in the north, okay? And we're going to get back to the southern hemisphere in a bit, but for now, let's head north, and let's go back up to like 30 degrees north. All right. Take the grids away. Oops, that's adding more of them. And let's talk about finding the celestial pole in your sky. So one trick you can use is know your terrestrial latitude. I live in Richmond, California, about 38 degrees north of the equator, which means my celestial pole is 38 degrees of altitude. That's where I will find North Star tonight. If I generally know where north is, and I can estimate from 0 at the horizon between there and 90 at the zenith above my head, I might say, well, there's 60 and 30, right? It's like a third of the way up, 30 degrees, 2/3, 60, 90 right above. All right, let's get back to down to 60 and 30. So somewhere in this zone is Polaris. And Polaris, there's not too many bright stars in that zone of the sky. Let's take some of the stuff away so you can see that truth. All right, I'm going to stop time here. When we're looking in the northern sky, there's some bright stars like Vega. But in this particular place of the heavens, like, it's just not that bright. Let me just, kind of keep that in mind, and we're going to look at some other places. Here's Altair. It's a very bright star. Here is Antares, the heart of the Scorpion, super bright star. Obviously, you see the Milky Way there. Here is, for example, bright stars like Arcturus in Spica, right? Other places of the sky have some brighter stars in the north, and it's actually helpful for getting to know North Star because there's just not that much luminosity in the magnitude of stars nearby. One group of stars that does show up in even the quite urban, light polluted skies is this group here. You recognize someone? Right? So, this is the Little Dipper, or part of the Little Bear. This is the Big Dipper, or part of the Big Bear. Now, much of the Big Bear, like Stellarium's drawing it in kind of a weird way, but into the head and the feet here, it's like really not that visible, actually. I think there's a way I can, in Stellarium and the sky and viewing options, I can go to star lore, and then I can show asterism lines here. I don't know what this thing is, but this bit is the Big Dipper, okay? And let me take that away. It's confusing me. Just take the constellation lines away altogether and just look at the stars. Do you see the Dipper stars here? 1, 2, 3, 4, 5, 6, 7. This is why they're called the 7 rishis in India. many names in many different places. They're very important because it's a very kind of prominent northern constellation, and it points to the celestial pole, right? So close to Polaris here in our day and age. And one of the ways that we can work with the sky and other constellations and do a little like kind of star jumping around is to learn the Big Dipper, or some say it's the wagon. I call it Santa's sleigh, and many other things. But the last two stars on the cup of the Dipper generally point towards Polaris. Let's bring these constellation lines in again, right? So these 7 are the Big Dipper. There's a lot of Dipper tricks, like you can follow the arc to Arcturus. Very powerful, very bright star. A fun one that the sky taught me is I can drill a little hole in the bottom of the Dipper's cup and it pours water onto the celestial lion. Oh, this is fun. It's kind of hard for me to tell where the stars are at this time. I'll do my learning on my own time, all right? Anyway, when you're outside at night, whether the lion's above the ground or not, a fun trick is like just drill a little hole in the bottom of the Dipper and then water is going to spill out on the celestial lion. It's a fun one. Maybe we'll see more of that in a bit. But the last 2 stars of the Dipper's cup, we call them the pointer stars because, while it's not an exactly straight line, generally speaking, you can draw a line from them to Polaris in the sky. And we usually teach it's about that length between the pointer stars and another 4, okay? Now, what about when, at other times of the night or the year, I'm going to bring in the sun. I might not see the Dipper, or it might be hidden behind a house or something like that. Stop time. Actually, let's go a little further. So here in Northern Africa, we're, remember, at 30 degrees north latitude, and this will be just as true at 30 north and Mexico as well. As you can see in these places, and it'll be easier to see if I take the sun away, the Dipper is not always above the ground, right? We just lost a pointer star down below the ground here, right? So what do you work with at that time? And the further south you go towards Earth equator, the further the Big Bear, Ursa Major, and therefore this asterism, this part of the constellation, the Big Dipper, will actually go down beneath the ground. You can't see it at all. There's another group of stars here called Cassiopeia, who is the queen on her throne in one of the traditions anyway. And many teach Cassiopeia as the W in the sky. Wait, what? I'm going to actually make these constellation lines a little bit larger. Here we go. That doesn't look like a W to me. Hold on. Oh, now it does. It will at another point in time. Because remember that everything is spinning about that pole, right? So how long does it take for everything to spin about that pole? A day, right? Why do we experience the sky spinning? Because Earth spins on her axis, yes? Absolutely. Earth spins on her axis in 24 hours, right? Yes, with respect to the sun, on average, that's a solar day, 24 hours, sunrise to sunrise. With respect to the stars, it's what's called a sidereal day, and that's like 23 hours and 56 minutes and change. But regardless, a day, okay? So let's call the day 24 hours. It's a lot easier to work with mathematically. How long is it going to take Cassiopeia from this point here where Cassiopeia looks like, well, I guess we could say a 3 to look like a W. And we're going to see some stages in between. Let's go forward in time. We'll see everything, well, at least the highlighted bits, especially the Big Dipper and Cassiopeia, spinning about that point in the sky. Little Dipper too. Let's stop time here. Now Cassiopeia is an M. How much time do you think passed by? I'm going to put the map away for a bit. We'll bring this clock in, okay? I'm going to just make this thing say 15:0. In other words, it's 3 p.m. In other words, remember, this is a time of the day when we wouldn't be seeing this anyway, okay? But it is happening in the sky, and at other times during the course of the year, Cassiopeia will be perfectly M like this during the night. So M, what's going to come next? And the answer is Cassiopeia is going to look like a E over here to the west, which, because we're looking north, is to the left. And that's going to be in a quarter of a spin. If the spin is 24 hours, approximately, a quarter of that time is 6 hours, right? So let me just take the stellarium clock here, and I'm going to go 1, 2, 3, 4, 5, 6. And now we have E Cassiopeia, right? Which is going to become a W in 1, 2, 3, 4, 5, 6. There's that W. And in 6 hours from here, we get the 3. And in 6 hours from there, M, E, W. Let's just let the sky spin. Cassiopeia is a 3, and an M, and an E, and a W every night. Although, of course, if we bring in the sun, part of this we can see, part of it we can't. As the sun is moving through the signs, that's going to change. Amazingly, somehow, we've been spinning so much, I've moved from February and it's now equinox. And I knew because I saw the sun was on the equator, which happens only at Aries and Libra equinox time. Anyway, bye-bye sun. We want to play with the stars, even during the day. Thank you, Stellarium Planetarium Software, for letting us play. So these are tools that you can use if you reside in the northern hemisphere to connect with your celestial pole in the sky, which is learning where Polaris is. One, you can work with the lataltitude principle, face north. A good way to know where north is, by the way, is work with the sun at midday. In the northern hemisphere, the sun souths at midday, so your shadow norths, right? Now you know the northern direction. And then at night, of course, just work with the altitude that is equivalent to your terrestrial latitude, and you can find celestial pole there. And in our day and age, that means Polaris, the pole star. We've seen how the Dipper pointer stars point to Polaris. Well, Cassiopeia, as you can see, and it's not exact, but generally speaking, Cassiopeia kind of opens up towards Polaris. Cassiopeia is a group of rather bright stars, especially considering what stars are available on that side of the sky. And the Dipper, in some ways, I guess it's maybe more precise in the just line of those pointer stars, but there's going to be times of the night and also times of the year where, depending on where you reside, the Dipper might be so low in your sky or even below the horizon that at a time like this, it's much easier to work with Cassiopeia because higher in the sky, right? So as you can see, they're not exactly opposite one another, but they're generally opposite from the North Star, and therefore when one is down, the other one's up, and when that one's down, the other one's up, and downs and ups all the way around, okay? Cool. So finding the pole star in the sky with your eyes, it's a very powerful thing. Let's globetrot a little bit more. But I've already given you the rules of how the sky is going to shift from one place on Earth to another. And these are kind of important tools, like the lataltitude principle, for not only getting to know your local sky, but to imagine how the sky works in other places, or to help you kind of adjust intellectually to your embodied experience of the sky when you get off a plane in a foreign place and it's like, wait, what? Most people won't in their lives even notice. Yeah, but we will. That's what we're here for. We are keepers of the heavenly happenings. All right. So yeah, it's another thing I want to share with you, actually. Let's talk lataltitude principle. I'm going to go to my home here in the Bay Area of California, which I have set up, and I showed you how to do this, I think, in the second or the third Stellarium for Astrologers instructional videos in this 2023 series that I'm currently making. But I can just go return to default location, and now I'm in Richmond, California. You can see the red arrow there, particularly the El Sobrante Hills of Richmond. And this is like literally the latitude and longitude of the office in which I'm currently sitting. Okay, well, notice that it's 37 north, 5822. All right, well, all astrologers, I think, know that there are 60 arc minutes in a degree, 60 arc seconds in a minute. So 5822 is pretty dang close to 60, and 5758 is very close. Sorry, 3758 is very close to 38, right? Basically, I'm 38 degrees north of Earth's equator, which I've said again and again throughout our flow today, and we should expect, therefore, that the altitude to the North Celestial Pole here in my local sky is like 38 degrees. There you go, the lataltitude principle. All right, well, the cool thing for me, since I'm studying astrology and practicing and teaching astrology, and especially the types of astrology I practice have roots in many places like Mesopotamia, especially Egypt and Alexandria, but also in Athens, Greece. I live at the same latitude on Earth as Athens. Let me show you how like the dippers work here where I live. We were looking last at a latitude of 30 degrees north of Earth's equator, and you saw how the dipper kind of went down underground a little bit. Here the bear like walks on the land. We're gonna see some tail stars or handle stars of the dipper setting, right? But for the most part, the dipper stays above the ground, always. And therefore acts like what the astronomers call a circumpolar star. Circumpolar stars are stars that never set in your location. And hopefully you've seen, right, as that pole gets closer to the ground, there's places where we could go where Cassiopeia even would not be circumpolar. Now, I mean, I don't love that name, by the way, because all stars are circumpolar. Like all stars are going around the pole. However, that's the term, right? Circumpolar stars are stars that never set. There's also, for every location, never rise stars. Like there are stars that I've seen in the southern hemisphere, or even in Hawaii, that I can't see where I live here in the Bay Area of California. All right, well, I'm gonna stop time here. And I'm just going to move to Athens, Greece. So let me just reset this location list and I will type that in. No, it seems like somebody added a country name. Well, it's a different time. Okay. Let's go. I'm going to go to right here, right now. So it's 10:53 a.m. Been at this for a while. You've been at this for a while. I hope you're enjoying yourself. Let me go back to my default location. And I can put the clock on the screen as well. And we see it's like, why does this say 9:05? Huh? Oh, I'm still on March 28th. Okay. So this is right now. Cool. 10:54 a.m. All right. Well, Athens, Greece is many time zones ahead of me or also behind me or whatever, right? Let's ask Astro Gold astrology software to relocate me from this 10:53:44 a.m. moment to Athens, Greece, where it is currently 8:53:44 p.m. Nighttime is the right time. So let's go to Athens. And you'll see that Stellarium astronomy software also like relocates the clock. 20:54 23. We were at 44 on the chart, whatever. Okay. The thing that I most want you to see is how here at 38 North in California, I'm having, though later in time, also earlier in time, since we are not talking about a timeline, but rather a time circle, the spinning sky. I have the same experience that Athens has of the heavens. Why? Because Athens, Greece is also 38 degrees north. Even more precisely than I am here. I think I'm 3758 we saw, and there you go, 3759, right? But there are definitely places in Athens that are going to be at the exact same latitude, terrestrial latitude where I am. So that's something I just kind of love when I get outside in the sky. I'm like, wow, folks in Athens who study the sky like I do saw the same thing like 10 hours ago. And yet it will be a little bit different because the moon moves quite far in 10 hours, for example. All of the planets, all of the wandering stars will have moved in that 10 hours of time. I mean, even in maybe the most interesting truth, like in Athens right now, it's nighttime. Bring the sun in down here beneath the ground. And where I live in the Bay Area of California, it's daytime. All right. But let's take the sun away. And what I want to do here is you can just keep your eye on the altitude, and I'll bring in that azimuthal grid so it's kind of easy to see of the North Celestial Pole. And now I'm going to, instead of changing my latitude on Earth and going down south to the equator as or up to Santa's place as we were before, I'm just going to move east. So I'm kind of changing time, right? Like I'm moving ahead in time as far as the Earth spins. I've already passed Athens, by the way. But everywhere at this same latitude on Earth is going to experience the same spinning of the sky. Why? Because of the lataltitude principle. The altitude to the celestial pole equals your latitude on Earth. So whether I'm 38 north in California or 38 north in Greece, like the way that we experience the sky will be the same, just displaced in time. Does that make sense? All right. I'm going to go back to Ploiești. And then let's go a few arc minutes north so that we're exactly at 45. And now we see that North Celestial Pole right at 45 degrees altitude, the lataltitude principle. I know that's kind of a silly term, but for me, it sticks. All right. So this is the experience of the spinning sky when we're looking north. from a location halfway between the equator and the North Pole, where therefore the altitude of the celestial pole is halfway between the ground and the zenith right above our heads up here. Now that might not look like halfway, but that's again because we're taking like a curved experience and flattening it out. All right. You, by the way, will sometimes have similar kind of distortions when you're looking around the sky. All right. What do I want to do now? Well, I'm going to bring the planets back in. And honor the truth that in the northern hemisphere, and then let me say north of the tropics, so I'm entirely accurate with the rest of this statement, the planets will be found traveling in the southern sky. There's sunset in the west over there. You can see them here because I'm completely bug-eyed, right? But if I want to go see those setting stars, then we're going to go look west here. And now I'm turning around to face the south. And let's bring the ecliptic plane back in, right? That's the sun's path, the orbital path of Earth, because our solar system is relatively flat. It is the place where you are going to find all of the wandering stars or the planets, certainly the constellations of the zodiac. Oh, let me stop time and I can bring some of them on your screen. There's the priestess and the scales and the scorpion and oops, I'm gonna start over. There's the priestess and the scales and the scorpion and the archer. Let me move forward in time. Get some other zodiac constellations to come up above the ground. And I can show the sea goat here and the water bearer and the fishes. Let's move through time some more. Oops, hey, that's not okay. Ram and bull and twins and crab and lion, and we've collected them all. All right, so now I'm going to let the sky spin more. And we'll just see how in this northern hemisphere, when we're looking south, in fact, I'm going to bring the meridian back in, which divides the eastern sky that ascends from the western sky, which descends. I can see how every day the planets, the wanderers, the luminaries like Moon, you see Mars here, it's like supersized, those fellas. Along with the ecliptic, and therefore the zodiac constellations, which are unique because they are the 12 constellations which embrace the ecliptic plane, they all rise every day, and then they reach, and then they will rest, and then they will root down below the ground. The sun is always traveling on the ecliptic, so it's aligned to the zodiac constellation. It too will rise and reach and rest and root, speeding up time. The computer is starting to freak. It's like making a lot of calculations right now, somewhere back in the ones and O's land. All right. But importantly, like you're going to see that the ecliptic, the yellow curve here, again, it's like, it kind of, I've heard it described in this way, which is fun. It's like a barrel rolling. Because the spinning of the sky, remember, it's on about a different plane. It's about the equatorial plane, not the ecliptic plane. Take the planets away. I'm going to slow this down. Every time I say slow this down for you who are learning to use Stellarium at home, I'm hitting J on the keyboard, and L will speed me up, and K will turn me to 1 second equals 1 second. 7 stops the whole thing. All right, so I'm hitting L, 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 L to get that spin happening. L again, and now a J. Right, so I'm still moving forward, but less quickly. So you're going to see some amazing things about the ecliptic, like the meridian, which is where the ecliptic intersects the meridian midheaven, the MC. It's where the ecliptic intersects the meridian above the ground. And you'll see that there are signs that culminate at high altitudes and low altitudes. As long as I'm speaking signs, I'm going to bring in a little thing you'll see right here, which is the solstice glyph. Okay, because signs and constellations are very different things. Stellarium knows this too. There is the place where Earth's North Pole is pointing 0 degrees tropical Cancer. And that might be a really weird thing to hear me say, and the pole's not pointing there, it's leaning there. I was speaking about that earlier, and I'm just going to leave that aside for now. I'm going to bring in the equinox points. So here's 0 degrees tropical Libra, which in our day and age is precessing through the constellation of the priestess. That's why I use terms like priestess instead of Virgo, because I like to use terms like Virgo and Libra for signs, and terms like priestess and scales for constellations. That's a very long story for a different time, one that I tell often and teach. The 3 zodiacs, the constellational zodiac, or zodiacs, because who gets to decide how to connect these dots and how to make boundaries between them. The sidereal zodiacs of the stars, and there are many, 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 because which star do you choose? And the tropical zodiac, which is absolutely not arbitrary at all. It's the only zodiac that is not arbitrary. We start with the point where, well, there's many places to start, one of them being where the ecliptic crosses the equator from the south to the north, and that's 0 degrees tropical Aries. Diverges from the equator most north at 0 degrees tropical Cancer, and I'm going to leave that there. In fact, I'm going to take the ecliptic away and the constellations away and the equinox and solstice points away. Here we are at 45 degrees north of Earth's equator, and we're facing south. And I'm just going to bring in this grid. I guess it will help for us to see the quadrants. I think it doesn't help, actually. Maybe if I thin out the lines a bit. Well, I'm not sure how to do that anyway, so let's just take it away. We'll leave the equator in, which is the plane of the spin, right? Earth's spin, and therefore the spinning of Earth's sky. And you can see the quadrants here. We call this in astrology the 4th quadrant, which is above the ground and going up. The 3rd quadrant, above the ground and going down. The 2nd quadrant, below the ground and still going down, descending. Let me take the ground away, and you'll see that the stars there are going down. And then the 1st quadrant, which is below the ground, but coming up, right? Because the horizon, which is the horizontal line of our chart, separates the above the ground that we can see from the below the ground, which we never will. We'll see the stars that are there once they rise, right? We'll see the stars that are setting until they set, and then they disappear. So we have the eastern sky, which goes up. But even there, we have going up below the ground, that's called the 1st quadrant, and going up above the ground, that's the 4th quadrant. We then have the western sky, which goes down. And there's a quadrant above the ground, which goes down, and the quadrant below the ground, which goes down. Okay, so let me say them again. First quadrant, below the ground, coming up. Fourth quadrant, above the ground, still going up. Third quadrant, above the ground and going down. Fourth quadrant, below the ground and going down. Now, you might ask, let me stop time here. Dude, can you not count? Why are you saying the first quadrant, the fourth quadrant, the third quadrant, and the second quadrant? I want to actually, even before I answer that question, turn around, because one thing you might be noticing here is like how different the sizes of these spaces between the celestial equator, the meridian and the horizon, which is the cross of matter, here east of the meridian. So this is the fourth quadrant stars, which are above the ground and going up. And that seems to be kind of very similar geometry. It always is when we're looking at the equatorial plane to this third quadrant, which is above the ground, but going down because it's west, right? Like what? But the ones below the ground, they're like so much bigger. No, they're behind us. So we're going to turn around here in Stellarium. Now we're looking to the west. Now we're looking north. Okay. And now you're going to see, if I just face due north, the exact same geometry, but beneath the ground. And now the ones above the ground look huge, but that's because they're behind us, right? Now, if I zoom in, we can't even see that at all. That's more like the human experience there. People will teach these things in astrology like, oh, well, the third quadrant houses have the same geometry as the first quadrant houses. Let me show you that on a chart. Those are the same as those. Let me show it to you at a time where it's going to look much more extreme to see that this geometry, third quadrant, okay, above the ground, but coming down because it's on the western side of the meridian line. These geometries of these houses or of this quadrant is equivalent to the geometry of the houses in the first quadrant. So the third quadrant they'll teach is just like the first quadrant as far as the geometry goes. I mean, that might get more interesting if we look at another house system like a Placidus house system. So, but you know, if I wanted to speak this in sky terms, I would say the houses of the first quadrant are like those of the third. Now, you might argue, what's the difference? If I say the third is like the first or the first is like the third, I can't see the houses in the first quadrant. They are beneath the ground. So if I want to like measure them or understand that they are a reflection of the third quadrant, then I need to know the third quadrant. Okay, well, why do I call this first? And why am I counting backwards? First, fourth, third, second. What? Let me just show like the sun and the moon. And we're going to move this through time. And let's stop it here. Here's the sun in the first quadrant. We also call this the first house. In any given moment of time, and remember, a chart is like a moment in time. We've stopped time. The stars or planets, if there are, in the first quadrant and in the first house will be first to rise. Planets that in the fourth quadrant will be last. Right? So, I mean, it really tells us the crucial importance of the ascendant, which in quadrant house systems like Placidus or the Porphyry house system I was looking at before, separate the first and fourth quadrants, like below the ground and coming up, but we don't really know, we can't see it, and we can chart it, and so we do know, and then above the ground where we can see and still going up. All right, so let's move this through time. Does that make sense? The first is the first to rise. The second house, by the way, is called a succedent house. Or let me look at it here. The 10th house is an angular house. Here's the moon coming to the angle, the midheaven. The 11th succeeding, because the stars that are currently in the 11th will succeed those in the 10th to the angle. Right? Now the sun's in the angular house. It's coming to the angle. The moon is in a succeedant house, the 8th. The stars in the 8th will succeed those currently in the 7th house to the associated angle, which is the descendant, where we descend from above the ground to below the ground. So moon moves from the 7th to the 6th. Here's the sun in the succeedant 8. The 8th stars will follow those of the 7th to the angle. The 6th is called cadent, falling. It's falling away from that angle. Do you see how that works? And in any moment, let me just stop. Whatever's in the 1st house will be first to rise. Whatever in the 12th house will be last, because it's going to have to reach up at the midheaven, rest down at the descendant, root down below the ground at the IC before it will rise again. Okay? So I'm not counting backwards. I'm honoring what is about to happen in the moment of stopped time. So here I see Orion falling from his daily height, while Sirius is still climbing. Everything will culminate at the meridian midheaven, which is not on the screen because the midheaven is where the ecliptic, not the equator, intersects the meridian. All right, in astrology, we're most of us are most concerned with the place where the planets live, and that's not the equator, it's the ecliptic plane. But again, it's not the ecliptic that is the plane of Earth's rotation, that is the equator, or we say celestial equator when we project Earth's equator into the sky. The spinning of the sky is our experience of the spinning of the Earth, and that's equatorial. And best seen in that way. All right. So as I said before, in the northern hemisphere, we're going to find the ecliptic in the south. Now that changes in the tropics and also in Arctic regions, but I'm going to stay temperate for now. I am going to move closer to the North Pole. Before I do, I want to turn with you towards the east. So we're now 45 degrees north terrestrial latitude. What is the altitude of the celestial pole? And the answer, as you know, is 45. This is a pretty cool look at that. I mean, it's impossible. We're looking east, but we can see north and south and beyond at the same time. I can even see the zenith right above my head and the nadir down beneath the ground. What? Okay, cool. Well, we can play. Thank you, software. But it's important to say, like, you'll never have an experience of the sky like this outside unless, well, enjoy your trip, friend. Okay, let's bring in that azimuthal grid, and we'll see here that at 45 degrees north, the North Pole is 45 degrees altitude. Have I said that enough now? Well, here's the 40 degree altitude mark, and here's the 50. And you see the North Celestial Pole right in between. Maybe we can zoom in some. There we go. We can just get a 45 degree line. Well, I wanted to show that to you as well, because you're going to see that the celestial equator is also 45 degrees. Oh, I see. So we found another rule. The terrestrial latitude is equal to the altitude of the celestial pole. And what I'm about to say is wrong. The terrestrial latitude is also equal to the altitude of the celestial equator above the ground at the meridian. That is wrong. Okay, so this is the one place where we're going to be tricked, right? Remember where the equator was when we went up to Santa's place, and let's go north now. I'm not going to go all the way to 90, but when we were at 90, the North Celestial Pole is at the zenith, 90, and the equator is 0. Oh, okay. And here at 60, the altitude to the celestial pole, let's have a more realistic experience of this. So now we're looking north, and it's up there, right, towards the top of the sky. And when we look south, there's that 60 degrees terrestrial latitude equals 60 degrees altitude to the celestial pole. All right, when we look south, what we're going to find is that the altitude of the celestial equator, where it is highest above the ground at the meridian, and that means for this northern hemisphere experience due south, is 30 degrees. So let me follow that curve up to 30 right there, right? Or 5, 10, 15, 20, 25, 30. Let's just zoom out and get 10, 20, 30, okay? In other words, 90 degrees minus your terrestrial latitude. We're going to do some impossible stuff again. I'm going to look due east and get the celestial pole, and the here's the celestial pole and the equator at its highest altitude, which is the meridian, both on the screen. Now, I understand that it looks like the equator is just going up forever, right? But it's just the tricks of the machine, right? So like this is where it reaches its height and comes back down. A hard time saying machine right then. Anyway, so north celestial pole at 60. The height of the celestial equator at 90 minus 60. So astrologers will know that the angle of the square is 30 degrees, right? So the altitude to your celestial pole is equal to your terrestrial latitude. The altitude to the celestial equator at its peak, which is at the meridian, is 90 degrees minus your terrestrial latitude. All right, or even, let me do it this way. I'm gonna look east again. Here's 60 north, okay? Well, the pole and the equator are perpendicular. So I'm gonna go 90 degrees away. Well, I'm gonna go from 60, 30 degrees takes me to the zenith, and another 60 degrees, right? So 30 plus 60 takes me to that highest point of the celestial equator, which is at the meridian in the northern temperate experience due south. All right. So the second lataltitude principle is the highest altitude of the celestial equator in your experience will be 90 degrees minus the terrestrial latitude of your location. All right, so at a place 40 degrees north, let's go 40 north, the celestial pole will be 40 degrees altitude, and the celestial equator will be 90 minus 40, which is 50 degrees altitude. It will also, by the way, if I turn around, and I'll never know by looking outside, but the software lets us play, it will be 50 degrees at its depth beneath the ground on the other side of the sky, right? Here's a north celestial pole at 40. Well, what's 90 from there? 30, 20, 10, 0, negative 10, negative 20, negative 30, negative 40, negative 50, right? 40 and 50 are like pairs in the square world. All right, so hopefully that will add a little bit as you choose to go and journey around. Let's take it down to the southern hemisphere now. I'm going to take this azimuthal grid away and bring in the equatorial grid. So we're looking at north celestial pole. I actually want to stay here. So we're 40 degrees north to Boulder, Colorado, and we're in Romania, I believe. We're closer to like Bucharest than where we started at Ploiești. We'll be south of there. Maybe it's in a different country, I'm not sure. I'm gonna look south. So we have a south celestial pole too. In the northern hemisphere, it's down beneath the ground. See how that plays? So we don't see it, but we experience it because everything is spinning about that point. Again, you know, I have a hard time with this definition of circumpolar stars, or the stars that never rise and set, because all stars are circumpolar. Check out how Orion is circumambulating that pole. right? Which is down beneath the ground. So a really powerful practice is, it's hard to do this here, but if we're outside, you can do it. It's like reach an arm up to your celestial pole. So if you're in the northern hemisphere, up to North Star, and then reach the other arm, do like a tilted warrior pose, and it will be pointing to the south celestial pole down beneath the ground. When you're over there, like watching the planets, for example, or the celestial or the zodiac or whatever, rising and reaching and resting and rooting, right? They're all traveling about that pole down beneath the ground. It's like a really powerful code to crack and learn. You'll start seeing the sun do this by day. You'll start really kind of integrating the importance of planets that are at the same parallel, okay, a distance from the celestial equator, because they will literally take the same path through the sky, rising in the same place in the eastern horizon, climbing to the same altitude, setting in the same place in the western horizon. But again, I'm getting into much more advanced things. Take my courses. More of them will be coming soon, so if you're interested, please sign up at my mailing list, geminibrett.com. So, South Celestial Pole, bring this back in. What's going to happen to that South Celestial Pole as I move further south on Earth? See how it's going to come up? Where is it going to equal the horizon? We found out Stellarium broke. It should be when we're at the equator here. Now that looks right. We fixed it. What happened? So I know I'm at the equator because we see 0 here. Okay. I think I'm somewhere in Kenya, but I'm not exactly sure. Which 26 degrees east longitude at the equator? Would love to know. It used to be quite easy to find out in Stellarium. It no longer is. All right, well, let's continue our journey south. Let's go all the way down to like as far as we can get in South Africa. So I'm going to make it 30 degrees just for easy math. All right, what do you think this altitude to our south celestial pole is? How about 30, right? 10, 20, 30. What is the altitude to the celestial equator going to be? How about 90 minus 30? 60. 10, 20, 30, 40, 50, 60. Good work. Except you had a hard time counting by 10 there for a little bit, didn't you? All right, well, let me take this azimuthal grid away, and I just want you to honor the truth that when you're looking at the ecliptic, the zodiac constellations, or watching the planets in the southern hemisphere, you got to look north. I'm going to be careful there and say south of Earth's Tropic of Capricorn. The tropics, things get more interesting. But the primary motion of the sky is east to west, right? Well, if we're looking north, that's from the right to the left. East is on our right when we look north. West is on our left when we look north. So the planets from the rise to the reach to the rest and down beneath the ground to the roots to the rise again in the southern hemisphere sky are on the anti-clockwise path. So this is not how we draw charts for the southern hemisphere sky, because the astrology chart, like the astrology wheels like this. Let's go right now. Bring some planets into this mix. And I'm going to relocate this to Cape Town. All right, let me bring some planets in so we have someone to see. Here's Mars. Let me stop time here and then set the clock to now. Here's Mars. All right, so Mars is in the 9th house of the chart, which means he's already reached his peak at the meridian. Like he's finished his time in this eastern side of the sky, which goes up. And now Mars is in the western side of the sky, which goes down. Particularly, he's in the 3rd quadrant, which is above the ground, but because it is west of the meridian, which separates the eastern ascending sky from the western descending sky, Mars is above the ground, but going down, chasing the Jupiter experience. Jupiter has just set in the west, right? So the strange thing is when we look at that and we compare the chart to the southern hemisphere experience in this planetarium software, it's like, wait, Jupiter's over here on the right of the chart, and Jupiter's over here on the left of the actual quadrant situation for the temperate southern hemisphere experience, because the sky, when we're looking towards the ecliptic side in the north, is actually spinning anti-clockwise, whereas we're going to model this still in the chart in this kind of clockwise motion of the planets through the houses. So that's just a challenging thing for those of you who live in the southern hemisphere, just to know that. I mean, I would advocate, and I am advocating, that astrology softwares like this one give me like a southern hemisphere button where I could then put the ascendant on the right, because when I'm looking at the ecliptic and the zodiac and the planets, the eastern side and the ascendant, which is where the ecliptic intersects the eastern horizon, is on the right. The issue is it's not as simple as a north-south button, because between the tropics, it goes both ways, or it works like the northern hemisphere sky part of the day and the southern hemisphere sky other parts of the day, like at the equator, which is neither north or south hemisphere and both. It works like the northern hemisphere sky with the midheaven in the south half of the day, and the southern hemisphere sky with the midheaven in the north half of the day. So it's not as simple as just like flipping the chart from the northern to the southern hemisphere experience. You're gonna have to actually do a little computer coding, which would be worth doing. Makes me feel like I'm working on a project with a friend of mine. All right. Maybe that's enough to show right now. Well, let me say one other challenging thing that's challenging for all of us, but more challenging for our southern hemisphere friends. If you're looking to see the astronomy of the astrology in the sky, one thing is like your local experience of the rising and the reaching and the resting and the rooting is every day is going to be counterclockwise in your sky from the east to the north to the west, instead of clockwise in the sky as we experience it in the northern hemisphere from the east to the south to the west. The other thing is, at this stage in the precessional cycle, you don't have a south star. So let's go look at where the south celestial pole is. And you know what, I'm going to go a little further down. So, well, should we just go float on the ocean, like ask a whale to give us a ride? Or you know what, why don't we also go very far west of there. This seems to be faster. And we'll go somewhere here, the tip of South America. And I'm currently, I'll just make this, 53 degrees south. Let's go 50 south, 70 west, wherever that is. So there are tricks, and I'll invite you actually to go look online and just search how to find the south celestial pole. So one way is to know your terrestrial latitude. If you were 50 degrees south of Earth's equator, then you know the altitude to your south celestial pole in the sky is going to be 50 degrees of altitude, right? 10, 20, 30, 40, 50, 60, 70, 80 zenith above my head. Folks use, let's see how I can do that. I think it's like this. There we go. Stop time. A few different constellations. So one of them is the Southern Cross, which is one of the legs of Centaurus, a centaur. And you can see that it kind of points to the south celestial pole here, right? So let me grab just a couple constellations. You're not going to let me do that? We had some keyboard shortcut weirdness. I forgot where we find this. Ooh, what are show ray helpers? That sounds cool. That might help. There we go. All right. So, you know what? I'm going to ask you to go online and look at some of the ways that folks work with the Southern Cross, which generally points towards the South Celestial Pole, and create triangles with other stars in the sky. I thought Alpha Centauri here was one of those, but maybe it's working with this triangle and I forget. You know what? Let's go online together. We're already spending the entire day together. Why not? Let's go have a peek at the World Wide Web. How to find the South Celestial Pole. You know, I've learned this and I've seen this in maps like this before, but until I go do it a bunch, it's worthless, right? Okay, the pointers and the Southern Cross. And it is Alpha Centauri, so Rigel Centaurus, which just means the leg of the centaur, and Hedar. So let's go do that. We could put this star away. Then we need the Southern Cross here. So what's done is you make another cross by drawing a perpendicular to these two stars, which are in this leg of the centaur. This is the star Alpha Centaurius Rigel Centaurus. It's the star that's closest to ours, closest to us, which is cool. Sounds. What we're told is that our sun and therefore our solar system is kind of like on a crash course with that star, and probably its solar system as well, which is an interesting thing. So this is like hard to do, right? But you've got to like create your own cross here and then work with that cross that you've created and this cross to triangulate the South Celestial Pole like this. I mean, even here, they're not even pointing to it, right? So here you go. We're making a cross out of those two stars. Let's just take this in time. I'm going to move forward in time. And we'll bring these crosses up to the arrangement that we're seeing in that particular illustration, which seems a little bit better. So through the Southern Cross, and then creating across through these so-called the pointers, Alpha and Beta Centauri, and the leading leg of the Centaur. And then we draw lines from both of them simultaneously, here and here, to triangulate the South Pole. And they're not even close by. Like, it's good luck. They are bright stars. They're super bright stars. The cross is amazing, and just, like, it's an amazing, amazing, amazing group of stars. That used to be part of Centaurus, by the way. It's another leg of the Centaur. But you know, who gets to divide the sky, right? Look at that one. Oh, the International Astronomical Union. Oh, thanks for that Ophiuchus weirdness, dudes. Anyway, yeah, so you know, it's a much trickier thing to do, but if you can work with that and then also work with the lataltitude principle, knowing that this altitude is equal to your terrestrial latitude, hopefully that will help. So let's just try like Melbourne, Australia, for example. Melbourne, Australasia. Melbourne, Australia. Australasia. Add to list. I'm doing that along the way. And let's move forward in time and get these pointer stars kind of up high. Well, Melbourne has a terrestrial latitude of, well, I was about to open the map and find out. Why don't I just open the azimuthal grid and find out. Here's 5, 10, 15, 20, 25, 30, 35, 40. It's right between 35 and 40. It looks like 37.5 degrees south. And that's pretty cool. I'm going to do that again. 5, 10, 15, 20, 25, 30, 35, 40. Wow. So it's just about as far south as I am north of the equator. I confirm that here. 37 south, 48. I didn't even know. I'm very connected to some dear friends and astrologers in Melbourne. And I find now that we are equidistant, condor and eagle, on other sides of Earth's equator. Yeah, so working with your latitude to get this altitude, and then triangulating, I guess. Let's bring in all the constellations here. Yeah, it's just tricky. Just tricky. And I would love to hear from my Southern Hemisphere friends if you've worked this, if you're getting more successful at this, what kind of tricks are you doing? I just want to look at one or two more images here. They're working with one more star, Archinar. I'll show you in Stellarium, you can actually do like a, you know, I'm on a Mac, so Command F like you can in most places. But it looks like they don't know Archinar. Archer. Nope. Well, let's see if we can find it. So I'm going to put the, oops. Put the cross kind of horizontal like it's shown here. Looks like can't do that, at least from the altitude or latitude on Earth where we are. And then go up to Archinar. What's a bright star nearby? This character? There you go. Yeah, and then that's helpful too, because see how it's like relatively equidistant from both the crossover here and the pointer stars of the Centaur. Yeah, I appreciate that they've added that one in because, you know, when I'm trying to draw these lines across the sky, how far do I go, you know, and having that kind of image by saying, all right, well, there's this bright star, Archinar, of, oh, it's like the river constellation. which is also seen in the northern hemisphere. That's going to help me kind of balance in. So now I can have my height, my altitude based on my terrestrial latitude. And then I can work with these two stars in my sky and go somewhere generally in between. Sounds pretty tricky, friends. Well, hopefully I've helped you make some of this tricky stuff, this astronomy of astrology, a little less tricky here. You know, another way, by the way, time-lapse photography can help. Like you're going to see all these stars are making circles around the celestial pole. And that's as true in the southern hemisphere, where they will move, clockwise, because you're looking at the southern sky. Okay, so if you look south, east is on your left and west is on your right. Or the northern hemisphere, time lapse, North Pole, where that northern sky spinning is counterclockwise, because when you look north, east is on your right and west is on your left, right? So you're obviously not going to see this in the sky, but if you just watch over the course of times, you'll get to see everything spinning. Doesn't take that long, a couple hours, you can really start noticing. Bring your tea. 4 hours, 6 hours, a quarter of the spin. You can actually learn to tell time this way. So if you can kind of learn to kind of see that point that everything's spinning about, you also have found your pole. As long as we're here, I want to just show you some graphics, thanks to the World Wide Web, of finding Polaris. Right, and so here's an image of working with the pointer stars of the Dipper to go there. I wonder if any of these have Cassiopeia as well. Looks like no. And hopefully showing some images from other creators online did not just make this video unwatchable in the future. I'm glad I recorded it. All right. Hey, thanks for spending so much time. If you've enjoyed this video, I would love to hear that, whether you're watching live right now or watching at some time that I currently perceive to be the future, and you giving it a thumbs up. Maybe share it around with folks that you feel would also receive something from this information. You could leave a comment. That would be really nice. I would really appreciate it. It's nice to know that the stuff that I'm putting out there is landing somewhere. If you feel of means at this time and would like to give something back for what you're receiving economically, first of all, your presence is the greatest present there could be, but you will find a donate button link scattered throughout geminibrett.com. You'll also find there some courses that you can take, the Earth Astrology Golden Year of lots of astrology classes, or my Sacred Astronomy course, previously recorded. Go through it at your own pace. You will find a sessions page or scheduling page where you can book a reading with me if you'd like, or do some one-on-one mentoring if you'd like to integrate more of this astronomy side or astrology, which I teach as well.